Okay, moving to flywheel energy storage system (FES). Flywheels, how it is used to store the energy or store the energy that we'll see in this particular class. So charging phase that is called as acceleration and the discharging phase is called deceleration. So in during charging phase that is it is accelerated. Acceleration, vehicle accelerator, RPM, increasing the RPM or increasing the speed or whatever. It's accelerated, increase the speed. Okay, so during periods of excess electricity, when we have excess electricity, and there is no much demand for electricity, continuous electricity flow is there. An electric motor spins a flywheel rotor to very high speeds, typically a very high RPM, rotation per or revolution per minute. So as the rotor accelerates, the kinetic energy is stored in its rotational motion, continuous movement. Okay, so that we will see. That means if we have excess electricity used, we have a system, a device, a bigger device, not a smaller one, a very big device, which has got air pumped out, or vacuum is created inside that, so that no much frictional forces, even air friction, are also avoided. And there are magnetic bearings are used. Magnetic bearings means it will not touch the machine part, but with the magnetic force it will make it to rotate, so that again it becomes more frictionless. And a flywheel is connected to the center. Flywheel means a heavy weight steel what is called wheel. Okay, and connected to a motor to start making it rotate. So when we have excess electricity, we have enough electricity. That electricity is used to using that electricity, motor is run and making this wheel to rotate, this flywheel to rotate. Rotate means not just rotation, maximum speed of as possible as speed, to that maximum speed it is allowed to rotate. And because there is no much friction there, the rotation, it is controlled by the bearing is the one which allows the parts to move without creating friction. So the bearing are made up of magnetic, therefore the wheel will rotate in a very fast speed, and it kept rotating because not much frictions are there, so it will keep rotating. Up motor is there, and to the maximum speed it is maintained. When the speed little bit decreases, motor runs and again it continues, and that speed is maintained, very high speed. That is called the charging phase, or it is the acceleration. Discharging phase or deceleration. That means when electricity it is needed, when we need electricity, when there is no sunlight energy, no wind energy, no tidal energy, no renewable energy, that time the flywheel rotor it is slowed down. Means we are not giving power to that, but still the flywheel is rotating at very high speed. That speed, that rotation speed, that can be used to convert back to electricity, because again there is a rod connected to that. Therefore, this rotates and connected to a generator. Generator means the one which can reverse it. Okay, initially it was working as a motor. Now this system is working as a generator. Because of this flywheel is rotating very high speed, the rotor makes the generator to rotate. When the generator rotates, when the generator works, we are getting the electricity. So this is how. So till the flywheel, that high speed flywheel, because of the heavy weight, it will rotate for a long time. Not just it will immediately, it won't stop. For a long time it will rotate. So we'll get required energy back unless until we get the energy supply from the renewable resources. This is the next storage setup called flywheel energy storage. Okay, so that's about what when it rotates we are getting back the electricity. Now the components, it has got a flywheel rotor, which is the core component of flywheel energy system. Okay, so flywheel energy storage system, flywheel energy storage, FES means flywheel energy storage system. So the rotor is a heavy disc or cylindrical designed to spin at high speed with minimum friction. Advanced material like carbon fiber composites are often used to create lightweight and strong rotors. Okay, so whatever material having strength as well as frictionless, such type of materials can be used to even replace this. Right now we have carbon fibers components are used to create which are lightweight and very strong material. Okay, now so second one, that is electric motor or the generator, a dual role. When needed, it acts as a motor. It rotates the flywheel or the shaft, and when needs the flywheel, the shaft makes the generator to run. Okay, so it is a dual purpose. Two roles are there, both that side and this side, so two-way role. Okay, so it acts as a motor during the charging phase, accelerating the flywheel, and as a generator during the discharging phase, converting kinetic energy back into electricity. So when it rotates in a 5 speed, that continuous work movement is there, that is called kinetic energy. The kinetic energy is used to get back the uh, electrical energy. It needs a bearing. A high quality bearing are essential to minimize the friction energy loss during the flywheel rotation. So therefore, magnetic bearings or air bearings are often used in advanced flywheel energy storage system to achieve almost near frictionless operations. Exact frictionless operations are still now not possible, but almost near the frictionless operations are now possible with the magnetic bearings. A vacuum chamber needed because if air is there, resistance will be the air resistance will be there. Therefore, vacuum is created by using a vacuum pump. Power electronics. The power electronic control the flow of electricity. This is power electronic system, the power conditioning system, and we need a control system to on and off. These are the components. Now merits and demerits. It has got high efficiency, up to 90% efficiency. It is now right now it is giving as per the studies, and it has got a fast response time. It can deliver power within milliseconds. It has got a long lifespan, and demerits it limited storage capacity compared to other methods. Energy loss due to friction over time. Okay, I'll stop this video here.